Good morning, everyone. So, welcome to my YouTube channel, Math Subject. So, today we are going to see a very important question. If f is restriction of Thomae's function on closed interval AB, then f is Riemann integrable over closed interval AB, and its Riemann integral is nothing but 0. Okay. Let's see how we show this. So, what is actually Thomae function? So, Thomae function, the Thomae function, which function T from R to R is defined by Tx is equal to, it is 0 if x belongs to R minus Q. It means if I am taking a rational number, it will be 0 and it will be 1 upon Q if x is equal to P upon Q belongs to Q, and GCD of P and Q is 1. Okay. It means P and Q are relatively prime. Okay. So this function is defined by this way. Okay. So note that there is a result. Or you can say theorem, or this is result. Thomae function P is continuous on R minus Q. It means every irrational point, but discontinuous at every point x belongs to Q. So T is continuous at every point x belongs to R minus Q, and it is discontinuous at every x belongs to Q. It means T is continuous at every irrational number, and T is discontinuous at every rational point or rational number, you can say. Rational number. Now, okay. So now we restrict. Now, what is the restriction? Now, next, F is nothing but restriction of T over closed interval AB. Okay. So this implies what is x? Fx. It is 0. So this is 0 if x belongs to closed interval AB intersection R minus Q, and it is 1 upon Q if x is equal to P upon Q that belongs to AB intersection Q, and GCD of P and Q is equal to 1. Okay. So this also implies that because Thomae function is continuous. So Thomae function is continuous at each irrational point. Thomae function is continuous at each irrational point, and it is discontinuous at each rational point. Therefore, F also will satisfy this condition on closed interval. So F is continuous at every irrational point in closed interval AB, and F is discontinuous at every rational point in closed interval AB. Okay. Now there is a result. There is a famous result. I am recalling that result. There is a theorem. There is a result that let F closed interval AB to R be a bounded function, then F is Riemann integrable over closed interval AB if and only if F is continuous almost everywhere. Okay, it is the minimum almost everywhere on closed interval AB. F is continuous. A dot E dot means almost everywhere. It means outside a set of major zero, it is continuous. Now you observe one thing. Now note that now F is restriction of Thomae function on closed interval AB. Okay. So points of, let's say A is points of discontinuities of F on AB is what? It is nothing but closed interval 0, 1 intersection Q. So this implies what is the measure of A? This is measure of this is less than measure of Q, but measure of Q is 0. Okay. So this implies what is measure of A is 0. Okay. So this implies F is continuous almost everywhere on AB. So this implies F is Riemann integrable over closed interval AB. Okay. Now what is its integral? Okay. Let P is equal to AX0, X1, X2, Xn minus 1, Xn is equal to B partition of AB. Okay. Then what is LPF. What is LPF? What is LPF? This is nothing but I goes to 1 to n mi delta xl. But what is the minimum? You take any subinterval, what is the minimum? Minimum will be 0 because f is restriction of closed interval AB, and it takes 0 at irrational number. Irrational numbers uncountably in closed interval. They are GANs also. Okay. So what is this? This is nothing but each mi will be 0. Infimum will be 0 because function is non-negative and it is taking value 0 at any subinterval, but because irrational number will be there at irrational number f is 0, so infimum will be 0. So this is, so what will be this? This will be 0. So we have, for any partition, we have this one. Now, what is, now f is Riemann integral over closed interval AB. We have A to B fx dx is equal to supremum of LPF. P is a partition of closed interval AB. Okay. Now this is 0. Every time this will be 0. LPF is 0. So LPF is 0. P is a partition of closed interval AB. Okay. So this is actually 0. So supremum will be 0. So this implies integral of A to B fx dx is 0. So therefore f is Riemann integrable. The restriction of Thomae function on closed interval AB is Riemann integrable, and its Riemann integral is nothing but 0. Okay. So today's question up to this. If you have any program related to this, you can comment on my YouTube channel. Like, share, comment, and subscribe my YouTube channel. Thank you very much for today's lecture. Thank you.